So I haven't got my electric motor yet, and I probably won't be getting it for a bit. The motor I was originally looking at getting, the Torqeedo Cruise Pod 12, I'm kind of a little bit annoyed at. Since I first emailed them over a year ago, they kept saying, yep, should regen your batteries, yep, should regen your batteries. Magic word, should. They stopped answering my emails, so I went to find them at the Annapolis Boat Show, ran into them. They said, come back tomorrow and we'll tell you. Came back the next day. Sorry, we haven't been able to find the answer. Let me talk to headquarters and get back to you next week. 2 weeks and a couple of emails later, I finally get, nope, sorry, can't regen your batteries. So I felt a little let on, I won't lie. I'm pretty annoyed at Torqeedo right now. There's a company called E-Tech. I think they're a Polish company. They have a pod motor called the 10 pod, which is a 10.9 kilowatt hour, and it will regen anybody's batteries, AGM or lithium iron phosphate. So right now I am strongly leaning towards them. I have some technical questions out to them, waiting for a response. But in the meantime, I don't really have any good way to do a capacity test of the batteries, which kind of leads us to me sitting around a bunch of unfinished walls with a big weird metal box beside me. I don't make it a habit on this channel to talk about things that are not related to either batteries or the boat, but in this case, my job is now related to the boat. We recently decommissioned a bunch of machines, and I wanted to get them because for my day job I write software, and I love having old hardware to test my software against. If my software runs okay on old hardware, it'll run fine everywhere. So I'm in the process of gutting and rebuilding this server rack. It's a bit weird to have a server rack in your basement. I fully admit that. But here we are. This should be a good load to be able to drain the battery packs in a relatively reasonable amount of time. I don't know what the draw is going to be once this is fully fired up. I'm going to guess around 2 kilowatt. We'll have to see. I don't want to bore anyone who's not a nerd, so I'm not going to go into too many details. But a little teaser for those who are interested. I've got a couple of APC Smart Ups. I think they're the SMT. I think there's the SMT or the SMX 2200 RM2Us. I have a couple of APC switched PDUs. The PDUs basically are smart power bars for each of the UPSs. I've got a couple of, what are these? Brocade ICX 6450 48 switches. My day job is redundancy, which is why everything here is in duplicate. And then from here, I've got a whole bunch of machines. All of them are older Fujitsus with one older HP. I hate HP, but I have to make sure our software works on it. Key thing is, all of these things fired up, even just sitting idle, should be drawing a fair bit of power. When I actually work with them, they should draw even more power. Again, I don't know what this is going to add up to, but I have two 20 amp feeds that go into the two UPSs. To get these working, I had to make a couple of 20 amp extension cords. These are the NEMA 520s for anyone who's a nerd enough to care. Clearly, I'm still cleaning this up and getting this ready. Currently, I've got two 20 amp feeds by the server rack that I had installed for this work, which I had to do when COVID hit and we had to all start working at home. Conveniently, I have two 20 amp circuits coming out of the Quattro. Perfect for driving the two power feeds going into the server rack. I should probably also mention that I have moved all of the batteries into the basement, specifically to be able to do this test. I had to get close to this thing. So I had to mount everything. Oh, shadows. Sorry, my basement's still under construction, so I don't have the best lighting setup. I don't have many working outlets, so I can't move my lights very easily. Key thing is, everything here is as it was before, except for that. This is the main disconnect switch and the pre-charge resistor, you can see it dangling down here, from the original battery. I cut it out and stuck it up on the wall, and that interrupts the main pack positive coming from the positive bus bar. It goes into the main disconnect switch, which then goes into this bus bar and back up into the Quattro. So when I'm ready to turn things on, I hopefully won't have the overcurrent discharge disconnect like I had before. You'll also notice that the solar charge controllers are missing. They are the two shielded BX wires here. They go upstairs onto the roof and up to the solar panels. Unless you've been around the channel for a while, you may not know, but when I set up the solar panels, I ran the BX, basically armored house wiring, down into the basement because I always plan to eventually move this stuff down here until it's ready to go on the boat. The flexible lines that you've seen that have been dangling by my office desk were always meant to be temporary just for the purpose of learning. So those are going to get removed soon. These will be lit up. I'll bring the MPPT controllers down here, but considering it's winter and I'm getting such pathetic solar generation at the moment, it's not a priority. So as you can see, I have a lot of work to finish setting up all of this equipment. I am not going to bore you with all of that. I just kind of wanted to show you that it's taken me a little bit to get this next video out because it's taken me a bit to get everything set up so that I have a load worthy of our batteries. I have a lot of work ahead of me. For you, okay, so that took a bit longer than expected, but it's done. Oh, and yeah, a wall got built while I was building my system. As a foreshadowing for cabling the boat, I like everything to be clean, but more importantly, I like everything to be functional. So everything is in waterfalls so that I can pull the machines out without undoing the cables. I'll show you what I mean. Should have tested this before I started the camera. There you go. And it just lets me get access to it without pulling everything apart. Let's get back to battery testing. So it's been a few days since I last had these things turned on. So the first thing I'm going to do, and it'll be the first time I've done this since I moved everything down here, if there's sparks, I want to catch it on film, turn on the Quattro and let everything charge up until they all go into high voltage disconnect, just to make sure that everything is absolutely topped out. They've already been top balanced. They've been sitting here for a few days doing any kind of interior balancing. The highest deviation is pack E with a 0.003 deviation. All the others are either 0.001 or 0.002. So they're very balanced right now. So this shouldn't take too long. So once this is done charging up, I'm going to go into the smart shunt and synchronize it to 100%. I can't remember if I need to synchronize the individual BMSs to 100%. I'll check that. But first, let's go turn this on. Yep, that's plugged in. Turn this on. Actually, no, I'm going to bring you closer. So this still thinks it's close to 100%. Turn on charger only. Okay, it's in bulk. 1130 watt. Oops, 1100. Okay, I'm not really a big fan of how it does that. 1100 watts going in. Hopefully this isn't too shaky cam. So I've got about 3 amps going into all of them. I don't think it's going to take very long for them to go into high voltage disconnect. It's pretty heavy shadows. I don't have any room for lights back here, so the lights are behind the camera. Lighting people, your job is a lot trickier, a lot more tricky than I expected. Cell deviation is staying nice and low. Actually, the cell deviation hasn't changed at all. I think these packs are super balanced. Actually, while that's happening, let me move. Should label which one is UPS 1, but oh well. There. Okay. They're taking more of a charge than I expected. I'll get the Victron app open. The fact that they're taking this much power has me slightly nervous about the self-discharge. I mean, it's not a lot, but I don't think it's a lot. One thing I haven't done yet, which I'm going to do before I start this test, and in fact, why don't I do that now while I'm waiting, is I'm going to set the high voltage at probably 3.55 and the low voltage at 2.6. I had a few people recommend that, and I think it's a great idea. There's no reason to let it go right down. Well, Andy's talked about that, as have other people. There's no point letting it go to 100% to full 0% based on the voltage, because there's so little energy left. Why risk potentially damaging the cells? Cell over voltage protection is 3.6. Let's set that to, you know what, let's do 3.5. 3.55, and I will set the recovery at 3.50. Under voltage protection is already 2.65 with a recovery of 2.6. I think that's happy, or that's good. I'm going to leave it. Under temperature protection is -10. Charge, no, that should be, I think I'm going to set that to 5 to 5 degrees. Under discharge over temperature, discharge over temperature recurrent return, charge over temperature recovery, charge under temperature. No, these are, oh right, because this is not always for lithium iron phosphate. I set it to, okay, I'm glad I checked this. Charge under temperature protection, set it to 5 degrees, let's set it to 2 degrees, and let's set the recovery to 5 degrees. Oh. Oh, I got those backwards, that's why. The 2, 5. Charge under temperature protection, degrees Celsius. 2, 5. Okay, I just had to do it in the right order. Okay, that is good. Let's go do battery B. That was battery B. Oh, that was battery A. Scan, wait, B. They're all still charging. For reference, I finished the top balancing Friday. It's currently Thursday, so for 6 days, the batteries have been just sitting here doing nothing. So whatever power is going into them is how much power they used since I did my top balance. I'm gonna see if I can figure out... Oh, the Victron app will probably record how much power is going into these. All right, settings. So I set that to 0.55. Okay, so I gotta set the lower value first. Then I can set that. Okay, under voltage I said was fine. I want the under temperature protection recovery. I want to be 5 degrees. And I want the shutdown to be 2 degrees. Just give myself a little bit of a buffer. I want 2 degrees because I don't know where the temperature sensor is going to be. Well, the temperature sensor won't be on the outer edges. It can't be, it's too short. So if I've got cold coming in from the outside, the outer packs might be getting close to freezing before the sensor knows it. That's my logic anyway. Really surprised these are still taking power. Oh, I forgot to check to see if there's a synchronized to 100%. Oh, there's a calibration amperage. I probably should at some point get a really well-known amperage draw and then calibrate that as well, but I'm not so concerned as with the amperage as I am with the voltage. Yeah, I don't see a calibrate to 100% thing. I could be just completely missing it and it's right in front of me, but... Okay, let's continue. That was battery C. If my boat gets to this temperature, I've probably got bigger problems anyway. Okay, I think we are done. Yeah, I think it's going to self-calibrate to 100% when they finish charging. So let's head back over to the Smart Shunt. I suspect by just the fact that it's hit 100%, it's going to calibrate to what 100% means. But I remember seeing an option that says battery capacity 680, synchronize. Okay, so when it stops charging, I'm going to synchronize. 0 current calibration. Oh, when there's nothing running, set it to 0. Okay, well, I'm not going to worry about that. Okay, now I wait. I love these JK screens. If you're going to use JK BMS, I highly recommend these screens. They're beautiful. But I wish they had an option for showing the wattage going into them as opposed to the voltage and the current. I mean, you can do the math, but it'd be nice if it was right there. Come on, I want to turn on the rack. I want to turn on the rack. Finish, please. I have to say, this, though there's lots of room for improvement, there's a lot of wires flopping about, and ignore this. This looks a lot more professional than that schlop I had on my desk. I was sitting here looking for the voltage so that I could press the pre-charge resistor to connect the batteries to the inverter. I forgot that I already did that. It wouldn't be charging otherwise. So yeah, that was already done. I'm looking at options to have a little panel voltmeter so I can actually see the voltage across the switch when I am pressing the pre-charge resistor. But anyways, that's neither here nor there at this point. Does the VRM show how much power I've put in? Ah, here we go. 400 watt hours. It said I consumed 0.2 kilowatt hours. Ah, right, I keep forgetting that the display up there is relatively low resolution. It's just, so it was saying 100%, but it's showing 99.7. I was just complaining about those other screens. Do one of the other screens show a higher fidelity? So the app is telling me 99.7. All 3 options on the battery are showing it rounded to 100. There it is, 95. So the Serbo GX is showing 99.5. The app is showing 99.7. I mean, it's a small difference, but why is there a difference? They should be pulling from the same source of data. Interesting. This is very exciting YouTube right now. This is the battery build version of waiting for paint to dry. Lucky for you, I can edit it. For me, I just gotta sit here and wait. Might as well stop the camera too. Turn off the camera and I'm sitting here thinking, why is it only charging at 3 amps? Shouldn't it be more? It's plugged into a 20 amp circuit now. It should be. I don't think I changed the Quattro. So go into the Quattro, go into the input current limit, and let's bump this up to, oh, come back here. 19 should do. There we go. And that is because it's plugged into a 20 amp circuit. NEMA 520. Ah, now we're getting some better power in. Now we're pulling 4.5 to 5 amps on all of them. Oh, 5.2. This should be faster. So now I go back to waiting for everything to charge. I'm really surprised at how much it drained. Oh well. And yes, my backdrop is my washing machine and dryer. Every house has a battery development area slash laundry room slash server room, right? That's normal? I think that's normal. I'm pretty sure it's normal. Hey, Tuck. Hey, Mr. Tatters. Keep me company while I wait for the batteries to top up. Seeing as I've already reconfigured the BMSs to stop charging at 3.55 volt, I actually think I should not resync it because it's synchronized to 100% at, well, it's 100% usable versus 100% capacity. Usable is what I care about. So it's probably going to stop charging before what it thinks is 100%, but that's fine. I'll synchronize to that because that's as high as I'm going to charge it in the real world, right? Because I've updated all of them to stop charging at 3.55. The voltage, the full charge voltage has changed. 3.55 times 16 is 56.8 volts. I don't think I've got the screen recorder working. No, I don't. Go into settings, battery, charge voltage. I had it 58.4. Now it is 56.8. That's 100% and it's updated. Okay. Discharge floor. I don't think I care. I want to go... I've called... What Victron's calling discharge floor is probably like the point where it's telling everything to shut off at 10%. I want... Oh, no, you know what? No, I want the inverter to not draw below 10% because I want to keep that in reserve for direct DC loads. Okay, so I'm going to leave that at 10%. Actually, while I wait, I had a few people comment in the last video that, well, you should have known to check your terminals when you saw those two batteries were out. Yeah, you're right, I should have. I didn't because I allowed myself to make an assumption. And my assumption was, it's probably not a connection problem because it's the two outside packs. So I thought, you know, if it had been like one pack and a middle pack or something like that, I probably would have been more quick to think maybe there's a problem. I saw the two outside packs and just assumed it had something to do with the way charging worked. That's why the thought never crossed my mind to check all of the terminals. I should have. Absolutely. Mea culpa. Hey, Tatters. We're charging at 30 amps. More specifically, we're charging at 1700 watts. Do you know what that means? Do you know what a watt means? You don't care. I don't blame you. Human stuff is silly. I am genuinely shocked with how much power is going into this. I should mention, part of the reasons why I'm so surprised at how much power is going into this is that I've had the inverter off completely. So it's not like the inverter was burning up a lot of power. I have had the screens on the whole time. But still, that's 12 watts. What would that work out to over 6 days? 12 times 24. It's 288 watts per day. Times 6 days is 1728 watts just for the screens, and that's not counting for the efficiency or inefficiency of the boost converter or buck converter. So I'm running at 1700 watts right now. That would be an hour of charging at 1700 watts. Wow! I didn't think 2 watts was very... Oh, buddy! Buddy! I didn't think 2 watts per screen was really that much, but yeah. 1700 watts. Man, that adds up in a hurry, doesn't it? And that's not counting the BMS's own internal discharge. Okay. I've got to be able to turn off these screens. Yeah. I need switches. There's worse ways to wait for the batteries to charge. I should mention, this is a bit close to me. With the walls and construction you see happening, one of the things I'm going to be doing is putting sound insulation in so that I can leave my stuff running and not hear it throughout the house. That's not done yet, so I'm not going to do a full discharge test in this video. I'm just going to get the test started, and that'll be the end of this video, just to show the new setup and whatnot. And then over the next several days, as I have this running during the day, I'll do the discharge test, and I'll do my next video as soon as it's dead. Where is it? I know it's around here somewhere. I know it's around here somewhere. Oh! There it is! There it is! There it is! Does that feel good? This is taking a long time. You know, there's times where I think 86 kilowatt hours is nothing when I'm thinking about range or heating the boat or various other things. And then there's times where I think to myself, 86 kilowatt hours is flipping massive. Everything in its reference frame. Okay, I've got 1.7 kilowatt hours in, according to Victron. And my math says that's enough to make up for the screens running for 6 days, which is insane, but mathematically accurate. So now it's whatever other parasitic draws were sucking out power. Okay, this is taking forever. I'm just going to turn off the camera. I'll come back and let you know when it's done. That took a long time. The Quattro's into absorption now. Let's go into the Victron and see how much power it's telling us we put in. Can I see that in this here, under history? Energy, charge, battery voltage. I want to see today. That's like history from the beginning. Maybe I need to go into the VRM. There we go. All right, it went down 6 kilowatt hours, 6.1 kilowatt hours. So with the inverter completely off, that's just the BMSs and the screens, it was collectively burning about 1 kilowatt hour a day. That's a bit higher than I expected. I think I might want to do some testing on parasitic draw, but not tonight. Tonight, we now go through, we're going to go into here. I don't think it's necessary, but let's go into the config, battery, synchronize. Sync to 100%, yes. History, I don't really want to completely clear the history, but let's clear the history. Okay, everything has been reset. Time since last full charge is 7 seconds. Let's turn on the inverter. Go back into the VRM. Okay, the inverter's on. Turn on the breakers. So currently I'm drawing 200 watts. So the UPSs come on, the PDUs come on, but the PDUs need a bit of time to boot up. So in a minute, these will all light up. There they go. I don't know if you could hear that. So they're powering up, and now, well, the switch is going to come online. I don't know. Let me just grab you. We are currently drawing 403 watts. UPSs are doing a self-test. Okay, they are not happy. They are not happy indeed. What's going on over there? Okay, that's not normal. These are constantly flicking. Have they finally stabilized? They don't normally do that constant flip over to battery thing. These may not like being downstream of these. Or more specifically, these may not like being downstream from here. Showing, am I really only pulling 371 watts? Yeah, 360 watts. So those are the dashboards, which is not going to mean anything to you. I don't plan to leave this on long because almost 11 o'clock. Oh, hold on a second. Why is this showing an error? I did say this is old hardware. I don't know what's wrong with that. I'll worry with it later. I want to fire everything up and see how much power I can draw. We're pulling 1400 watts, 1500 watts, 14. I'm only pulling, I'm really hoping to pull 2 kilowatts, otherwise this is going to take a long time to finish this discharge test. 1650. I don't know if I'm going to hit 2 kilowatts. I hope this isn't too loud for the mic. 18, oh, almost 18. Come on, 2 kilowatt. All of these are platter drives. For the nerds who are watching, these are all platter drives, which helps you understand how old they are. But they draw more power. Ish. 1600 watts. Now granted, they don't have operating systems on them. They're not doing anything, they're just booting up and running out their own power. But during the boot up cycle, it should be using more power than if it's just idle. I was really hoping this was going to pull more power. Alright, if this holds at 1500 watts, it's going to take me 57 hours to drain the batteries. The reason I'm laughing so much is that these UPSs are considered fairly decent and high-end ones. These are actually relatively new equipment. We had to buy them for a job we were doing. If I could get 45 minutes of runtime out of these, I was generally pretty happy. 57 hours. Wow. Oh, this one has an error too. Thankfully, I've got a pile of parts I can steal from. I have a feeling when I edit this up, it's going to be one of my shorter videos, but I'm not really sure what else to do in this one because I don't want to hold up the next video waiting for this to discharge. Besides, I think that's going to be a full topic on its own. So I guess I'm the Digital Mermaid and let the draining begin. I'll talk to you soon. This is really cool. I mean, okay, I got dead parts, but who cares?